Hey guys, it's Nerdnick, and I'm bringing you part 4 of the How to Design Dollar Tree Foam Board Planes tutorial. In this video, we're going to be covering how to complete your fuselage, how to design your formers, and we're going to talk a little bit about control surfaces as well. In the last few videos, we've gotten up to the point where we have a side view of the fuselage designed. We have our vertical stabilizer and our horizontal stabilizer mostly done. We've also designed the wing, the spar, and our airfoil for the wing. So let's jump right into the next part. What we want to do for the fuselage next, now that we have the side view already done, we want to create the top plate and the belly so that we have a completed fuse. With my power pod that I've already had imported and been using for measuring and comparing sizes, I'm going to place it over this top view of the plane and get an idea of how wide do I want to make the plane. The simplest way to go about this is to make the fuselage just as wide as the power pod is once it's assembled. This gives you a nice consistent narrow fuselage, but if your plane has a more rounded nose or angled, you may want to design where the power pod sits to be not quite as snug for the fuselage. So what I mean by that is if my power pod is going to sit right about here, you can go straight down for the fuse, and now you're losing some of the shape of the fuselage here, but the fuselage is going to be basically the same width as the power pod once it's designed. Or you can choose to go a true angle of the fuselage, and then the power pod will kind of sit freely. You have to add some guides, and it makes it a little more difficult to align everything, but you get a nice shape of the fuselage. If you're going to go with capturing the true shape of the plane, one thing to keep in mind is that the top plate and the belly that we're designing sit in between the two side fuselage walls, excuse me. So if you were to draw out the side plate on this line, the foam actually is going to come out to here when you then glue everything together, because this would represent the side wall. Okay, so whatever you're going to do, you need to make sure that you are accounting for that. So even though I draw my line here, if I'm going to follow the exact line, the foam's actually going to extend out to about here, right? It's actually going to be right about that width exactly. So the plane's going to be a little bit wider than you think. So make sure you account for that. So with this plane, I already decided I'm just going to do a straight fuselage. I'm not going to bother with hugging the curve. So what I want to do is figure out where is my motor going to sit. We talked about this in the last video of making sure you have the right depth so that the motor can sit properly inside the fuselage, and then just enough sticks out for the prop. And on this plane, right about where the exhaust pipes are here, across this front line, is a perfect spot. The sidewall of the fuselage is going to extend up to this line, and then the motor is going to sit right about here, which, just for reference, in this plane, it's about 3.45 centimeters. So I'm going to go with that. So I'm going to go ahead and start with my first line, and I'm only going to draw half of the fuselage, a belly and top plate. I'm not going to go all the way across because I'm going to mirror the piece over. So I'm just going to go just past halfway, do my straight line over, and when this power pod is built, this side plate here folds up on top of the bottom plate. So this red area is actually, it's gone, it disappears. Since the sidewall folds up, it actually sits right about here. So this is where that piece sits. Okay, so the width of your plane, if you're going to keep it the same size as the power pod, needs to be this line here. Okay, the first line. And just as a little example, I brought in a piece from my chipmunk just as a reference. I grabbed the fuselage part to kind of show you what that looks like. So if I were to lay this over, this is where the chipmunk would sit. And then if I look at the power pod now, the inside line here is as wide as the entire plane, because on the fuselage, this side plate sits next to the bottom plate. So this red line on the inside becomes the width. So the diameter, I'm sorry, the length here, this is your whole width of your plane once it's on the inside, so where your power pod needs to fit. So for the actual power pod, if you notice the size, it's slightly smaller. And I do this so it's not a super tight fit, because if you make it the exact same size, then you don't have a little bit of a gap, and it makes it really hard to install your power pod. It makes it hard to get everything to fit right. So you want to leave a little bit of a gap, but not too much, because then there's too much movement. So again, the width of the plane would be in line with this inside line of the power pod, but give it a little bit of wiggle room. Okay, so with that being said, we're going to go back to our power pod now. We're going to put it back in place. We're going to come right up here, get our line tool, start a little bit before or past halfway, and I'm going to come just a little bit past the line, and I'm going to go straight down. And I'm going to go straight down until I feel like the plane is going to start to taper. Okay, so on this design, up until probably right about here, there's a gradual outward bend for the width, and then it starts to gradually come in. But then right about here, it's going to really start cutting. So I'm gonna pick right there for my line, and then I'm going to look at the rest of this. So the line, then I need to decide if I do a straight line in, am I happy with that? The fuselage is going to end somewhere around here, but am I happy with that amount of curve and amount of angle? And I think so. Again, the foam's going to come out to about here once it's there, so we're not losing too much. And there's no way to do a really nice clean bend with the foam and still remain strong. You can do a bend by removing paper and kind of working it, but on this sidewall, you really need, this tail section needs to be very strong. You don't want any movement or wiggle when it comes to how your horizontal is glued in and how the tail flexes, and you don't want that movement. So that's a good line for me. Now, before I actually connect the line, though, I need to make a decision. Where's the fuselage going to end? Where's it actually going to stop? And to do that, there's two things you can compare. You can compare where the hinge line is on your horizontal, and then also where the hinge line is on your vertical. So if I go up here and grab my vertical stabilizer, I'm just going to grab it and I'm going to move it now. I need to get an idea of where is this fuselage supposed to end. Some planes, the fuselage will swing. The elevator will swing into the fuselage, and you have to cut grooves and everything. On this plane, if I look at the side image, the fuselage ends actually right in line with where the rudder is. So right basically on this line, and that's what I've already designed here. If you look at the image, I've designed it to stop right there, right for the length. So I already know that's kind of where I want it. So I need to figure out where that is on this image, because I can't really see underneath. I can't see that. But I do know where the hinge line is on this guy. So this is going to sit right here in terms of its depth down. So I know that's going to happen. And then by looking at the other image over here again, I can tell that the hinge line on the, actually from that image I can't see it very well. What I want to see is where the hinge line for the rudder and where the hinge line for the elevator line up. And we might have to do a little measuring, because this is not the best image to see that. It looks like though that I can see a cut here, which would represent this line, and so then I need to figure out how far from this line to the elevator is there in distance. And it looks like actually the elevator is going to line up just about right with the end of the fuselage. So I'm going to call that good. I'm going to say that where the elevator swings is where the fuselage ends. And this can be tweaked a little bit later if we need to, but for right now that's what I'm going to do. So what I'm going to do right now is go right to the middle. So if I look at in the middle between. This should be sitting right in the middle of the plane. And the way I do this is I grab a line, and I'm looking at my measuring tool, which is popping up here. I don't know if it's recording or not, but as I draw this line, it tells me the degree, it tells me how many centimeters it is. Now once I draw that line, I can see how many pixels long it is. 437. If I cut this in half, that will give me exactly halfway point. Now I'm not going to try and do math, so I'm just going to do my calculator here. Where are we going? There we go. And we're going to say 437 divided by 2 is 128. We'll call that. Or sorry, 218. So if I do this 218 now, I have right in the middle. And then from the middle, I need a line that is going to be 0.5 centimeters long. So if I draw that line right now, that's 0.5 right there. That's perfect. And then I look at, oops, it joined with my other one. I don't want to do that. 0.5 centimeters. I now have that. And if I zoom in, I can actually get an idea of what is the middle here. And that looks good there. Okay, so now I have a perfect middle line. And what I need to do then is, so the reason we're doing this, just to explain, is when you build your middle belly section for the plane, you need to make sure that whatever angle the sidewall of the fuselage sits at, and this is determined by this piece, when the fuselage ends where it meets pinching the rudder and the horizontal stabilizer and the vertical stabilizer, it needs to be as the width of a piece of foam so that the stabilizer fits in there. It kind of slots in. If you don't account for this width, then the fuselage doesn't narrow properly and you have a big gap, right? Or if you measure it too small, then the fuselage comes together too sharp of an angle and you can't fit the rudder in there properly to line up. So one width of foam is what you want. Again, 0.5 is a good amount. And I actually moved this. I don't know why. I think I clicked it on accident. So let's go ahead and reline this up. Okay, and this needs to be right on the hinge line. Oops, that's not the hinge line at all. That's way below. Okay, so this is good. So what I need to do is I need to move this line from here up to here while keeping it in the middle. So how do I do that? If I click and then hold shift, I can now drag this line and it should move in a straight fashion. So if I click and then move up, I can't move left or right. I'm trying to move left or right, it doesn't move. If I go up and down, it's perfect. This can also do left or right. So if I click and then move left first, now it's locked on this line. I can't move it up and down. Okay, so to move it in place without having to sit here and just wiggle it with the mouse keys, you just click, hold shift, and then you can drag it up. And we're going to put it right about there, which is where we want it. And then if I go back up here and I start my line, now all I have to do is meet it right there. Actually, I'm a little bit off, so I'm going to redo this, and we'll start on this side actually. Zoom out a little bit. We'll click here. We're going to go up. So there's that, and then we're going to go ahead and join these three lines. Actually, this last line is the middle piece. We don't want that. We just want these two lines. And we're going to call this belly for now. Okay, so we have our... Where's... I think I missed a line somewhere. There it is. Okay, so this needs to join to these two. So there's our belly. Okay, so what I want to do now is I'm going to go ahead and copy this. I'm going to open up a new tab. I'm sorry, not a tab. I don't know why I said that. A new document. I'm going to paste it in, and I'm going to go ahead and swap it over. So I'm going to go to image, and I'm going to rotate it horizontally, and then I'm going to copy it again, and I'm going to paste it back in. Okay, so now we have a copy of that other side, and we're just going to line it up. So we're going to bring it just a little bit wider than the power pod, and then make sure that it's lined up here. And then what that should leave us with is a nice finished connection. There it is. And again, if we look at the width on that, it is exactly 0.5 centimeters. Perfect. Okay, so what we want to do now is clean up our other lines or anything we didn't want, so we get those out of there, just so they're not cluttering anything. But we have essentially the belly of the fuselage. And if I look at how the fuselage is designed, it's fairly straight. We have a flat bottom, then we have our curve that begins here. Now, if I had a significant curve at any point in this plane, the belly may require some changes. You might have to remove some of the paper on the inside to get the right curve, or you might have to add hinge joints so that the belly can curve. That's just really going to depend on the plane that you design. In this case, the bottom is flat, and then I have a gradual curve up. So I really only need to add one hinge point right here. But where is that hinge point? So what I need to do is I need to grab my belly. Actually, we need to join these two pieces together first. So we have both sides of our belly. Okay, so I need to grab my belly. Remember we talked about the exhaust lines here? This is really important to note when you have a 3-view image or a 5-view image. You want to make sure that everything is proportional together. So I know I see the exhaust pipes here, and then I also see them here. So I know where my starting place is. So if I grab my belly and I do a Control T and rotate it while holding Shift, get it back to a straight 90 degree. And if I move it up here now, if I put it right in place there, oops, right where the exhaust pipes start, I now have an accurate placement for the belly. And sure enough, it ends right there with the hinge line. So that's perfect. So in this case, I was right on with the hinge line for the rudder and the elevator being the same. But now I can also see, where does this need to bend? And if you see, it's actually way back here. So the easiest way then is to look at where the bend is. And in this case, it's actually before the taper, which is a little interesting. Most planes right around the taper is where the bend goes. That could just be my design, choice, or it could be the plane itself. So in this case, this right here begins the bend, so I need to add a line right here that indicates that there's a bend necessary. Okay, so I'm going to go ahead and drop my line, and I don't care that it's too long, I can erase that, and I'm going to change the color. So I use, just like Flight Test uses a blue, which indicates a crease. We don't want to cut all the way through, we just want to mark it with a ruler or something so that you can bend the foam and then it starts to gradually turn. Because this is the bottom plate, right? So it needs to be straight and then bend up. So now I'm going to go ahead and rasterize that, and I'm going to move it underneath the belly so that the blue line is underneath the black lines, and then I'm going to quickly just erase this line. There it is. So there's my crease line. And again, I think this will be okay. There's not a lot of curve here, but it's one thing to note from the bend, is it a straight line up to the end? And if I look, it's fairly straight. There's a little bit of a curve. I think I'll be okay. If the curve is too much though, then what I'll end up having to do is remove or make a section of underneath here where it has our paper removed so that the foam can actually bend with the bottom of the plane. In this case, it's okay. So we've got our reference line there. That's how you'd find the reference line. You can line it up with the fuselage. You can line it up to find, you know, where those placements are going to be. That's how we're going to do the formers as well. We find the placements of the formers. But for right now, we're going to go ahead and join these two pieces together, and we're going to say our belly is okay. And now we need to decide how we're going to join all this together. So the belly itself is almost done. There's two things we want to do. One, we want to cut it a little bit shorter than it is right now, because you don't actually want the belly to extend all the way up to where the power pod is placed, because then you don't have any room to slide in your power pod or mount your battery underneath. You need to have a little bit of an opening. And this is really just a decision you have to make. There's no right answer. The further back you go, the more open the nose is. Also, the weaker it is. The further up you go, the less space you have to get stuff in. So on this plane, it's a pretty gradual curve. I'm just going to bring it back about this far and call it good. If this is too little or too much, when we get into the design phase, we can modify it, but this is a good place just to start. So now what I want to do though, is I'm actually going to, before joining this, I'm going to copy the entire belly layer and I'm going to paste it. So I now have I should have two layers that are the same. There's my belly. And what I'm going to call this one is just belly 2 for right now. I did that because we're going to reuse this to make the bottom plate. And we're going to use the current one to make the top plate. Okay? So what I want to do is, now that I've decided where is it going to end, I want to cut off what's here. Okay? So I'm going to go back to belly 1. I'm going to grab my either eraser or my select tool, and I'm just going to go up here and delete. That's good. And then I'm going to join this with belly 1. So there's my belly 1, and this is actually going to be the top plate. So we've got that part of the top plate, and then we need to decide where is the end going to be, or how do we want to actually do this. So generally, I would say the end should be right where it starts to taper. That's the best place to do it. Then you don't have to deal with a tapered piece outside of the top plate, or outside of the cockpit. Now, you can go further, you can bring it back further if you want, like a stronger boxed in tail section, but really you'll have a closed-in bottom, so you just with like one support for a former is usually enough to give it enough strength. So I'm going to cut mine right at the taper port. Okay, so we're going to grab our line tool, go to the taper line, and we're going to go ahead and cut that. And we're going to do two things now. We're going to remove the blue line, which we probably should have done this before I added the we should have cut this up before I added the blue line, just so I don't have to undo work. That's okay. We're not in a hurry here. So we're going to go ahead and delete the blue line. We don't want that anymore. And then we're going to delete the rest of the tail here because that's not needed. Okay. We'll go ahead and clean this up. So that's good. So we now have the top plate. Okay. Now what's important here is we're gonna try to join this to the fuselage now. Okay. So we already have the fuselage side. That's what I'm selecting here. So we're gonna go and delete that. The fuselage side is already there. Okay. What I need to do is take this top plate and I'm gonna move it up. Still, oops. We need to join this line first. So we went and joined those. There we go. Now I'm just going to move the top plate up. And it's already in position now. Don't have to move it left or right. Just have to up and down to find the right size. So we already decided how wide the plane's going to be based on the power pod size. And now we just need to make the A, or the B fold, the canal here. And to do that, I'm just going to figure out what is 0.5 centimeters. And it's right there, and I'm going to move my top plate right into place. So just to verify now, from about the middle of the line, I measure to the middle of the line is 0.5. It actually is a little bit longer, so I'm going to bring it down just a smidge. So I'm going to bring it down one click, we'll double check. We really want this joint to be tight. That's perfect now. We don't want it to be too wide, otherwise you run into issues with stability and strength on the sidewalls, or you have to add a lot of glue and extra weight to make it, you know, nice and sturdy. So we went ahead and added that. Now I'm going to go on this side and I'm going to add that same line here. There's my cut line. And I'm going to actually move this one just so it's nice and square here. There we go. And we essentially have half of the fuselage done now. All I want to do ultimately is go over these two lines with red so that they're my cut lines, and I'm just going to redraw those. So I'm going to come right to the middle. We're just going to draw that up. We're going to end there. We're going to turn this red. I'm going to do the same thing on this side. Get it right into position. Those are perfect overlaps now. Go check on this side. That's good enough for me. Alright, so we've now added our cut lines and we've joined the top plate to the fuselage. So I'm going to go ahead and join all these layers. And then also I'm going to join it to the fuselage. Okay, so now I essentially have one half done. All I'm going to do now is I'm going to select this whole thing, the whole fuselage that I have now, copy it, open up a new document, paste it in, and then flip it over. Rotation vertically. And now I have my other side. No need to repeat work here, I've already made it, so I just copy it over, and now I'm going to line it up. So this, the black line that's here already is this first red line. That's my alignment, okay? So when I line it up, I want to make sure that that is in place there, and then up here I need to make sure these are the same as well. So I'm going to move this forward, and then I'm going to drop that down. I should have a nice, clean line now. And now I'm left with a black line here, so I'm just going to go ahead and erase that, because that is not what we want. We don't want that overlap. So delete this. So far that looks good. I'm going to go ahead and join these two to make the complete fuse. Rename it here. Whenever the layer is whatever layer's on top, when you merge them, all the layers take on that top layer name. That's why I have to keep renaming these things, because the positioning and stuff, so it's kind of confusing, but really renaming them is important because I won't remember what layer 3 is when I have 20 layers. So renaming them, even though I have to do it constantly, is very helpful when I need to go join the layers. Okay, so we've got our top plate joined to our two sidewalls of the fuselage, and we still have our belly now. And the belly, again, is going to be a little different in terms of position. And what we can do now is we can go back to our original image, and just to double check, where the taper starts is actually going to be right where this ends on my design. So I can look at that and I can measure it that way, or I can also look at where my smokestacks, right, my exhaust started. So I know that's the line up there. So now, again, this is important because I want to make sure that I have the proper bend line. I want to make sure I have the proper length. Just double checking. I'm going through, always looking at my work and making sure everything still lines up. After you make some changes, sometimes it doesn't, and you want to account for that. So this looks pretty good. So now, one of the things that is important to note with this design, the bottom plate is going to sit in between the sidewalls of the fuselage. So the fuselage here on this side is going to be the lowest point. The foam is not going to sit below, it's going to sit in between. And to make it nice and clean, we're going to add the paper cut out on the side, so that when you build this, the paper wraps around and then it covers the foam, just like FT Mustang and the rest of my NN designs have that same setup. Looks really clean, looks really nice. To do that, what we need to do is do a little measuring. Now that we're sure the length is right, we're sure that the taper is good, so we don't have to redo any work later. We want to make sure those are measured now. Okay, so we're confident it's good. I'm confident in, actually, this is good. See, we're doing our measuring and I just caught something. When I did my belly to top plate switch, I moved my top plate in too far. That's where the belly's supposed to go, not where the top plate's supposed to go. So I need to fix that really fast. I need to move this back up into place, and I need to move the top plate to how far this is. My belly right now is too long and my top plate's too short. So this is why we need to double check this stuff. Always pay attention as you're making these changes, and even once we're all done, before we do any printing and any testing of the plans, we're going to remeasure certain parts and we're going to double check everything. This is taking forever, so I'm going to click and hold shift and move it up. Okay, so what we're going to do is we're going to bring out these red lines and we're going to close off this front line here. Okay, so we're going to go ahead and repeat that line in black, and then we're going to draw these lines in red. And actually we need this one to be further, so I'm just going to leave that for now. Okay, bring this one down. Oops. This one into place, and we're going to make it red. We're going to put it on top of the fuselage. Make sure these are all lined up nice. This looks good. Looks good. And I'm going to go ahead and draw my black line here. I'll make it just a few pixels longer so I can select it and go into here. I'll do 62. Nope, too much. Oh, 60. Perfect. I'm a perfectionist. I like to be nice and clean. Okay, so now that we have that done, we can go back to what we were calling the fuselage, and we can erase this line right here. Oops, too much. There's that. And then we can go ahead and join all these shapes we just did to the fuselage. There's done. And now we can take our belly and we can fix the length on the belly. So we said before that we wanted to go, I just kind of guessed, right? There's not really a right answer when you're doing this, but I'm going to call right about here what I want. That should be enough room to get the battery and everything that I want to do. Okay, so we're going to do that, and we're going to select the belly and just delete that. Okay, so now that we have that line, we're going to join it. This is the belly now. And we need to add the paper overlap pieces now. So to do that, we're going to go back into our belly, now that we actually know it's the right length and everything, and we're going to add a line that is about 0.5, the width of foam. You can make it a little longer if you want to overlap and have an extra bit of cutoff, or you can go a little bit shy so it's a nice clean cut. I do it right about even. So I'm going to draw that between 0.47 and 0.5 line. I have my all my different joints, okay? So I have one at the beginning, I have one at the first bend, and I have one at the end now. 0.4, there it is. Okay, so now, if I go over this, shift so I have a nice straight line there. There's that. And then what I'm going to do is I'm going to go back over this middle line, and we're going to turn it red. So we want to 50% cut this line. And this doesn't have to be perfect because we're actually going to be erasing this underneath line, right? We just need to get basically the same angle that we had before so we don't cause any other issues. So we got that. Now I'm going to select the belly and I'm going to erase. Oops, actually I want to I guess change the color. This one, make it red. So we'll switch that over. We'll go back to the belly and we'll keep erasing. Just like the other one, there it is. Got that. And we're going to go ahead and erase again underneath here. Take this one now since it's straight. And delete. Okay. So now we have half of the belly done. We're going to go ahead and join all these pieces again to the belly. Actually, except for we don't want these. This second one here in the middle, we don't want that one. We want the end one and we want this front one. So we're going to go ahead and delete this layer. We don't want that. And we're going to join the rest of these to the belly. So there's our belly, and you guessed it, we're going to select half of it. And we're going to go ahead and copy, new, paste, and rotate. Copy it again, bring it back over, paste it in, and line it up. The red line in this case is the black line on the original piece. Make sure that's nice and straight. Looks good. Looks good. And just to be sure there's no underneath hanging around, we're going to go ahead and select all of this and then select the original piece and open. Now we just have the new piece that we copied over and then the original piece. We can select and join those and rename it to belly. So now we have a true belly piece that's ready. Last thing that you might want to do is add a air hole. If you want the nice closed design that this is going to offer on underneath, but you still want to have some good airflow, you can go ahead and add, your cutout here. They say your cutout's supposed to be, so much % bigger than your intake, but really since the nose is so open, you can't really do that on these designs. So just having something here is good, because you'll have enough airflow then going through just to cool down your ESC and your battery, or whatever you have tucked away inside the power pod as well as underneath. So again, there's not really a true answer here. Just make sure it's centered. I just kind of threw those together. I'll move it around, but it's pretty straightforward, right? There's nothing complicated there. So there's my hole, and I'm just going to join this to the belly for now, because we can go back and move that if we want to or make it bigger, but that's perfect for me right now. One other thing to take note of is the placement of your vertical stabilizer here, your rudder. As it comes around and comes in, this piece of foam is going to sit up inside of here like this. So when you look at exactly where it's going to sit actually, right about there. So if that's the case, and this comes in, then there's going to be a contact point, right? You can't actually have a full sheet of foam and the vertical stabilizer sitting in the same space. So you either need to cut a groove or you need to remove the foam here. What I've done is I've figured out how far in I'm going to go, and then I've just cut and said remove paper and foam. That way this whole part is just paper, and it just then glues up real nice and smooth. So that you'll need to decide based on the plane that you have, the design that you have. That will vary based on the shape of everything. So once you get to that point, make sure you keep that in mind. Okay, so with this plane, I would need to decide, all right, that's the end, my belly with my vertical stabilizer. Oops. It's over here somewhere. Where did I put it? There it is. So I haven't actually decided how far I'm going to come in with it just yet. But even just the amount I've done there, if I would have decided, or if I decided to cut it straight up right here, then I know with my belly that I have to cut off that much, right? Or notch it or groove it or whatever. But in this case, I'm literally just gonna cut it. I'm gonna add a line to remove. I'm gonna go a little bit past it, so there's you have a little wiggle room, and I'm gonna add this as a 50% line. So I'm gonna make it red, and then I'm gonna join this to my belly. There's my belly, and then I'll go back later and add the text, the instructions of what you need to do there. But that part's good for now, so I can just move that out of the way. Okay, I'm gonna go ahead and save since I haven't done that in a bit. Okay, so the last thing we're going to look at is the formers. Now this plane, like I said, is pretty straightforward. It's really just half circle, kind of rounded over. With my placement right now, I have my fuselage sitting over my side view, so it's in line. I've got my horizontal there. I've got my belly basically in the right place too, so I can kind of see where everything's going to line up. I can see where everything sits. With that being said, I need to look at now the curve of the plane. I know for a fact that the top plate is going to sit at this height when it's all glued together, because this top plate folds down and then occupies this space here. Okay, it does not sit high, it's flush across the top. So with that being said, I know exactly how tall my former needs to be with this placement. If I wanted a former right here, I would know it's exactly this tall in the middle, the highest point. If I wanted the former here, I know it's exactly that tall, right? So I can get an idea of how big my former is going to be at the highest point. But that's only part of the decision here, or part of the design here. So I'm going to design this so my poster board, starting right about here, I'm just going to pick this line, make a nice straight line. From here to here, there's not going to be a former. It's just going to have a bend point, and it's going to come down and have a little bit of a gap here. And it'll curve naturally. So I'm not going to worry about that nose piece. And then I'm going to add a former right where the cockpit window is going to start, right here. And then I'm going to add a former at the end of the cockpit. And actually, since this is the plate ends right here, I'm just going to pick the plate placement. So I'm going to put it right there. There's my next former. And then going back, I'm going to throw another former right here. And actually, no, I'm going to put it right at the groove point, just so I have a nice little marker right there. And then the last former is not going to exist because the poster is going to rest on the vertical stabilizer. So there's my former placement. We've got one in the tail, we've got one at the edge of the fuse, we've got one at the beginning of the cockpit, and we've got one on the nose. Now, in terms of how long the plane is and everything, once I get it printed out and look at it and then start to really hold it, I might need to come back and say, you know what, I need to add more because the gap's too big, right? The poster board is too weak on those spaces, but I don't know that yet. So I'm just going to start with this for right now and then make that decision. But I think I'll probably end up having to add one over here, but we'll get to that when we have to. So for right now, I know that right here, the height of the former is this. And I know that the width of the former is this. Actually, it's both red lines. It's as wide as both red lines. Now, I know that because we decided the top plate, right? We already built it. So with that being said, what I need to do now is I need to take this line right here, and I need to move it. So I need to grab it. I'm going to move it up to the middle. I'm going to Control T and spin it. And I'm going to put it right there. That's where it's going to sit. And now we're going to draw this from here That's how wide the former needs to be, and this is where it's going to be sitting. Okay. So now that we have that, we're going to do a nice curved half, and then we're going to copy it over and make it all symmetrical. So to do this, I'm just going to kind of eyeball it as I'm going, and then we'll make changes if necessary once it's made. So this will give me a nice gradual curve, and I think it looks great. I think that works nice. So I'm just going to join all of these except the middle piece for the height. I don't care about that one anymore because we already determined the height. So this one can go away, deleted. Everything else is going to get joined together that I just designed. Actually, we've got more there. So we've got, actually, where's the first one? That's the last one. So this to this get merged. There it is. So there's my piece. Now I'm going to Control Alt, Control Copy, and then go into a new document and paste it, and then I'm going to flip it around. Go back to my original, paste it in. Actually, I should have clicked first. If you click first, then it should. It's supposed to bring the, there it is, the paste in pretty close to where you are. Okay, so again, I need this to be as wide as the wide red lines, the second red lines, okay? So I've got layer 14 and layer 1 there. We're going to go ahead and join these. We're going to go ahead and make sure it's all good there. That's good. My height looks good there. And then I just need to connect this, right? I was a little bit shy from the middle, but that's perfect, nice flat, right in the middle. Nice perfect curve, okay? So those three now get joined together. I've now got, I'm going to call this 1, that's my former 1, and what I'm going to do to the top plate is I'm going to add a marker for number 1. So I'm going to go ahead and get my black on here, and I'm going to pick my font and my size. This is all, you know, relative to the plan size. I think I'm using 18 font of my my bold TW Century MT. I don't know what it's called. There it is. There's my name. If you have Photoshop or whatever, you can grab that same one. It looks nice. It's nice and bold. But I'm going to put that right where I want my former to go, just as an alignment. And then I'm going to go ahead and draw one more one, and I'm going to Control T it. Oops. Not sure how I brought that out. Control T. Okay, there we go. I'm going to hold down Shift, and I'm going to rotate it. Oops. I don't know how it came out weird. That's supposed to come out perfectly. Let's try this again. 90 degrees. it does 90, and I think my computer's kind of slowing down because the file getting so big. It's like almost a gigabyte. Actually, it is more than a gigabyte. Let's try this again. So T, hold down Shift, keep holding down Shift. Let go of my clicker. Let go of Shift. All right, there we go. Now we have a nice lined up. I'm going to go ahead and put the number right there, and then I'm going to join this 1 to 1. So now the 1 has a 1 on it, and I'm going to join the 1 to the fuselage, which I think I renamed to something else. There it is. No, 1 to the fuselage. Merge layers. There we go. And I'm going to go ahead and grab this guy. Oops. The 1 and move it out of the way. That one's done. Former 1 is done. So I'm going to go ahead and repeat that same thing for the rest of these, since they're all the same shape. The only one that's going to change is this one. So we'll go ahead and do that right now. This one's going to be the same in terms of the design, and this one's going to be the same in terms of the design. The one that's different is this one. So we're going to do the same thing that we already did in terms of the width. And how do we determine the width on this one? With our bottom plate. So that's why we have it lined up here. We've got it perfectly lined up. So if I go ahead and grab the belly, click and hold Shift so I can move it up, put it in place. There's how wide it needs to be, and in this case it needs to be black to black. That's how wide it's going to be, okay, for the dome. And then this is our height. We know that's our height. So we're going to do the same thing. We're going to build it the same way. The only difference now is that we need to add the bottom pieces like this so that it sits inside of the tail, right? So now it's actually a little mushroom guy. So when we do that, how we determine that is once we build the width of it and build the angle, we will come in the width of the foam on both sides. So this gap right here needs to be 0.5, okay? On both sides. Go 0.5 centimeters, and then draw down. The length that you go down is the height of the fuselage. So if I hide the belly from the inlet cut that I make, so if it looks like this, there's my little mushroom, my little dudes here. This line right here is going to be from here down as far as you want to go, but not past about here, because then your bottom plate's sitting in here. I recommend not going that far. I would say go about about halfway or whatever. But there's not really a right or wrong answer. As long as you go about halfway, you're gonna get the same amount of strength as if you go down all the way. So you'll design that. I'm not gonna cover that right now just because it's something that we can, you guys can copy what I've done, and you don't need to watch me sit there and do that again. So for right now, I'm just gonna go ahead and move the belly out of the way. So I have that. I've got my first former. I'll go ahead and recreate the next ones. And then you guys can make your formers there. If you have the image like I did on the de Havilland 88, you can simply copy the angle of all the formers and then overlay them. So what I like to do is, let's say you have your former 1, right? And right here you had a graph that had all of your formers. So you just traced them all, you made all your sizes. But because you're not dealing with perfect scale, like when we were doing our fuselage width, we cut it narrow, the taper is a little different in the tail. The former then is going to be the wrong size. It's either going to be too wide, or it's too narrow, or it's too tall or short. So what you need to do then is take the former that you designed, bring it over to your fuselage, line it up where it needs to go. So in this case it's 1, and then make sure it's the right width. Make sure it's the right height. If it's not, you can do a Control T, because you might design it and it ends up being like this big, because your fuselage is wider on the scale version than it is on the Dollar Tree one. So then you have to bring it in, right? You have to shrink it and make it fit perfect. So you have to play around with that depending on which plane you picked, how close to scale you chose on the width of the fuselage, the length, the taper, everything. So that is one of the benefits if you do decide to make the fuselage exactly as wide. Like when we did this line, if we had gone the width of the entire fuselage, accounting for the foam again, so we don't want to go all the way, we want to cut it 0.5 centimeters short. But if we did that, then when we made the formers, if we had plans for them, they should line up perfectly. They should line up right where you want them to line up. So something to keep in mind, something to take note of when you're doing your build. The more scale you make it to the drawing, the less adjustments you have to make or be aware of and account for. But these are pretty small changes, and they're not too big of a deal. All right, so the last thing I want to talk to you guys about that I didn't cover in my last video is control surface sizes. Some planes that you pick are going to have some very small or very large control surfaces, and that can produce some unnecessary or undesired flight characteristics. Just as a rule of thumb, the larger the control surfaces, the more area you have, the more drastic the effect is going to be based on the amount of movement you give it. So a big control surface, you only have to move it a very small amount to get a huge amount of input, and the plane will respond very, very quickly. It'll respond very drastically. That's why you see like 3D planes, they have huge control surfaces and they have huge amount of throws, so that's like double whammy, because they need really, really precise, really quick control. And then very, very fast planes, ones that don't need a lot of input, they because they're traveling so quickly that a small amount of input translates to a large amount, they have smaller control surfaces. Smaller control surfaces are great for the faster you're going, because you can cause the plane to do whatever your roll, your elevator, your pitch change, whatever you're going to do can be with a very small movement, and that translates to less drag. So a very large control surface on a fast plane isn't the best design, because even though you don't have to move very much, you're still moving a lot of the surface, which causes a lot of drag. So you're going to slow down then on your turn or on your loop or whatever. So if you can do the same amount of input and cause the plane to react with a smaller control surface on a fast plane, then that's ideal. On a slower plane, one that you want to have you know, a lot of stable on, a little slow flying, you know, just a real light floaty plane, the bigger control surfaces are better. So the control surface that you want to look at, you know, what is bigger, what is better, is my scale one good? You know, what's the right proportion? There isn't an exact, but you can get a kind of an idea based on the percentage of the plane. So when it comes to the rudder, the Spitfire rudder is crazy. It's very large. It has a lot of authority. It has a lot of input power. So it is big. This is a large amount of surface. Same with the elevator. And the elevator and the rudder actually have a unique design where instead of being a straight line and then just a flap for a control surface, they have this little groove. And this is important because as the elevator moves up or down, this section right here kind of causes a unique thing to happen. Because it's not moving just up or down with relation to the stable part of the surface. It actually creates like an additional surface or additional angle of surface that the wind's going to catch. So it's very effective. It's a very it causes a lot of drag, so it's not great for a fast plane, but it's very effective. So very small amount of input feels like a crazy amount of input. On this design, you'll need very, very little elevator throw to get a very, you know, a responsive turn or elevation climb out of this plane. And that's not just because of how big it is, but it's because of this specific part of the design. So if you're looking at a plane right now that you're designing and it has a straight piece and you're not super worried about it being perfectly scale, but you want to know it has good input and it feels good and it has control, I would highly recommend adding something like this to your design. This will take your elevator to level 11, right? It'll turn up the notch there quite a bit, and you'll have a lot more control of the plane than you would on a smaller design without this. Okay, so when it comes to then the proportion for a elevator on the horizontal stabilizer, this one accounts for, we're just going to do quick math here. This is 4.61 centimeters out of 7.8. So it's almost a third of the entire surface is the elevator. So I would say that's huge. A third would be ginormous if you had that, and probably unnecessary. But if you're less than that, if you're down in the quarter or even less than a quarter, you're getting into the very small throw. You're getting into the very small. You need to be going fast to have good control. So I would say between a quarter and a third is a great place to aim for if you're making adjustments or if you notice your control surface is too small. When it comes to the rudder really, depending on what you're trying to do with it, if you're looking at slow flight, the rudder is very important, so you want a bigger one. In this case, it's nearly half of the whole surface, if you see this. And again, this is not a small rudder by any means. This is a very large rudder, but this gives very good control. So very slow speed, you don't have to roll with the ailerons. You can get good response out of a rudder that size. So half would be extreme, really great. Down to a third would still be totally acceptable. Anything less than that, and you're looking at something that needs to go faster, which you don't even really want a rudder if you're going that fast anyway. So yeah, just something to note. So the last part is the ailerons. Right, so what do the ailerons do, and what size? Or sorry, what do the different sizes do to the plane? Now, this is kind of a tricky one because the shape of the wing, the size of the wing, the angle of the dihedral, all those things also matter when you're looking at control surfaces for your ailerons, and they will produce different effects. So I can't give you a direct answer on what's the best for every type of wing, but I'll give you some general guidance to look at. With an elliptical wing like this, the ailerons are going to produce like a somersault roll. The plane is not going to spin perfectly on the fuselage axis. Okay, not like a 3D plane or not like a mid-wing plane with a straight wing. Those planes are going to have the most symmetrical roll, and they'll roll pretty quick too. So those ones you don't need a huge amount of throw, and you don't need a huge amount of aileron surface. On an elliptical wing, the roll, like I said, it's going to be more like a somersault. It's not going to do a quick rotation right on the fuselage axis. It's going to kind of do a barrel roll. And with that being said, having the larger aileron surface and having a decent amount of throw is going to be helpful because this plane's going to turn slowly. Now, this one does have the clipped wing, so it's going to be a little more fast in its roll compared to the standard Spitfire, but it's still an elliptical wing that's it just doesn't have a great roll tendencies. On a straight wing, again, without a lot of curve, the roll rate's going to be a lot faster, and then your wingspan's going to matter too. The larger your wingspan, the slower the plane's going to roll. The shorter the wingspan, the faster. And that's a scale comment. So if your plane, even if this plane, if I made it 10 feet long in the wingspan, it's going to roll significantly slower than the same design plane that has a 5-foot wingspan or whatever, because it's not the wing change, it's just literally there's less mass there's less drag, it's a smaller plane, smaller wing. So if I took this same design with the same fuselage width and I made the wing super short like this plane would spin like a torpedo. It would be super fast. So the total wing length is going to matter quite a bit. A 40-inch wingspan plane can only roll so fast without crazy amount of input or huge ailerons. It's only going to be so fast. So if you're in that size range, then that's good. 40 inches is good. That's kind of what we're designing around. So when it comes to how much throw do you need, how big of a surface do you need, these are, I would say, relatively small for this plane. The FT Spitfire has really big ailerons. They come out to the wingtip out here, right? Because this comes out, and they're like up here. They're super big. And then the FT Mustang has nearly half of the width of the wing in terms of the length, and then it comes up about a quarter. So it's huge. Those are huge control surfaces, but they give you a very, very responsive plane at slow speeds, right? Because you have so much movement, you have so much area moving that you don't have to be going very fast to get enough air moving over the control surface to get response. So again, if you want a slow flying plane, make your ailerons big. Now, when we designed the wing, we talked about some of the parts of the bottom wing and some considerations you need to have when determining how far down the trailing edge is the bottom wing going to sit. If you make your aileron bigger in terms of how wide it is, then you need to adjust the bottom plate on your wing, because then you're going to have overlap. And also, if you make the aileron too big, let's say I was like, yeah, I want huge ailerons, I want this plane to be crazy, you're going to introduce some different characteristics of the plane. One, the more wingtip surface that you remove from a stable standpoint, so the fixed part of the wing is not going to move, just the aileron, right? The more of the wingtip that disappears into the aileron, the more tippy the plane can become at slow speed. So even though you think, oh, I'm getting all this great control by these huge ailerons, you might be introducing some stall characteristics, because when you move your aileron, you're actually making the wing now only this wide. And you can introduce some unpleasant results. Now, like with everything I'm saying, there isn't a direct answer. There's not a direct science there. There's probably some equations that I don't know about. If you do know about them, let me know. That would be awesome to try to understand. But you are going to change the way the plane handles and feels by doing that. So just be aware of that. The other thing too is if you cut too much out of this bottom plate because your aileron's so big, what you're going to end up with is you're going to have to add a bunch of spacers right here so that your trailing edge lines up with this part of the wing, because as the wing airfoil is designed, right, this part is going to climb, it gets steeper and taller. Right in the middle is the tallest part of the wing, and then it gradually comes down. So right here, the wing's like almost an inch thick, right? There's a lot of space in between the spar and the bottom and top plate. So if your aileron's cut in, you have a huge amount of space that you have to make up for with spacers. Now, that's not a big deal, you can add spacers, but what you're doing then is you're introducing even more drag into the plane, because the aileron is going to be sitting flush with the top plate, but then there's a huge gap on the bottom plate between the bottom plate and then the aileron. Again, you're creating flaps, almost always down flaps. And just to make that clear, I'm not saying you're creating the ability to use flaps. I'm saying it's like you're flying around with your flaps down all the time. When you have your trailing edge on the bottom super high, and if you have your big gap here with spacers, you're essentially flying around with deployed flaps. So maybe you want that. Maybe that's something you want, right? You want a very slow, very gentle, very stable plane, then great. That's something you can do. Otherwise, just be cautious of that, because you are going to introduce a huge amount of drag into your plane. into your flight. So other thing then to note is, okay, so what's a good size for my ailerons? Again, based on some of the FT stuff and what I've seen other, you know, kind of beginner planes or intermediate planes, almost half of the length of the wing is pretty common. That's a big surface in my opinion, but you can get away with that and be totally safe. So I could extend this down to about here and still be fine, right? If you're not looking to build a super trainer and you just want something that's going to have enough response, but you don't want it to roll crazy, then something like what's here is a little bit better. And this would be a little bit more than a third. So if I look at the length of this this wing, you know, we're looking at about 50 centimeters or so, right? Halfway. So halfway point on this to, let's say 240. I did my math wrong. Yeah, dang it. So this line is 5,800, 2,500, 2,900. Yeah, that's right. There we go. So there's half. To go, I'm sorry, I said I was going to do a third. I don't know why I just did a half. That's too complicated math for me. So a third would be, just from eyeballing it here, I'm going to say right about here and then right about here is breaking this into thirds. So a third is going to would be totally sufficient. And then in terms of the width, the total width of this plane is about right where the middle of the aileron is about 19.5 centimeters, about 20 centimeters. And the length of this is roughly 3.8. So that's a good a seventh, maybe an eighth, or whatever, a sixth, somewhere around there would be a good amount in terms of the width. You could go thinner, but again, you're going to lose your slow speed ability, so just keep that in mind. This one's sitting about a seventh, and then just over a third in terms of the length. So those are good things to shoot for, good sizes to look at. You can base it off what you have, but if your plane scales down and then the surfaces are way smaller than what we just talked about, what you can do as an adjustment, since you've already decided your fuselage length, you've already decided your fuselage height, everything, you can just make this bigger this way. You don't have to cut it in this way, you can just trace it out and give it more surface this way. Make sense? And then also on your ailerons, if you can't cut them in too much and you don't care that much about scale and you just want something that flies well, make them bigger, come out this way and just cut them in. Add a tab to it, right? Different planes have those. That all that creates more surface area and can then, you know, produce a more effective result depending on what you're trying to go for. Or if you need to make it smaller, right? You want it to be faster. You don't care about the big movement. Cut it in, right? Drop the scale a little bit and make an adjustment. Once it's built, no one's going to know. No one's going to be able to see it, but it will fly significantly different. Alright guys, so that's going to end part 4. We completed the fuselage, we made the belly plate, we started the formers, gave you the idea of how to make those, and then we talked a little bit about control surfaces. I think this video has gone on long enough at this point, so thanks for watching guys, and stay tuned for part 5.